Hi, everyone. So there weren't that many questions on this 7 and 8 document, which is good. I hope that means that you are all finding these units to be the review they are intended to be for the most part. So I'm going to go through some of the questions just orally. There are some that were just kind of quick questions on the notes, and then I'll go over the more specific ones in the FRQs. So the first question we had was about molecular geometry structures. You are not actually responsible for drawing them, so there are no more that you need to know how to draw than any of the ones that I gave you. I do think the ones that I gave you are good just to have knowledge. For example, what a bent structure looks like, the basic ones. I think it's important for you to have that kind of knowledge, but the more complicated ones you absolutely do not need to know and or will be required to draw. The next question is along the same lines. It says, do the two different bent structures, 120 degrees versus 109.5 degrees, need to be drawn differently? No, I do not anticipate that you will be drawing any structures, but you should know the angles. The type of question that they would ask you about this would be an MCQ that says, what is the bond angle in this structure? And for then, it's important for you to know if it's the bent with 120 or the bent with 109.5. That's the type of question you should anticipate. Not that you'd have to draw them differently, but you do need to know what the angles are. That is the main reason that I put it in the summer assignment, so that now you are just reviewing the stuff you memorized over the summer. That's why this whole chart was in there. Without the hybridization, obviously, because you didn't know what that was at that point. But yeah, that is why it was in the summer assignment. That is why you already had it memorized, and now you're just picking up to refresh your memory. The last question on the notes says, where does the S, P, and D come from, and do they need to be memorized, or is there a correlation depending on the electron domains? S, P, and D come from the electron configurations. Remember, those letters are for the subshells. The S subshell holds 2 and has 1 orbital. The P subshell holds 6 and has 3 orbitals, all of that stuff. I think that's what the question's getting at, but obviously if this does not answer that part of the question, please make a comment on this video and I can clarify. They shouldn't need to be memorized because hopefully you remember SP and D from electron configurations, because that's such a common thing we did. But if you don't remember, then yes, you should memorize them. In terms of the correlation, the exponent should add up to the electron domains. Okay, so for example, if you have 3 electron domains, you have to have S, which just has an exponent of 1 at all times, which you don't write, and then P, which can have up to an exponent of 3, because remember, the exponents are showing the orbitals. Okay, now here we need a total of 3, so it would be sp2. The invisible 1 plus the 2 would add up to the 3 electron domains. If you had 6 electron domains, you would have S, P can have up to 3, because those 3 orbitals, and then that gives you 4. You need a total of 6, so you would go D to 2. Okay, we don't do any that have over 6 electron domains, so this is the highest one you should have. All right, so that's the correlation between them. So those are the questions I had on the Vesper notes. If you have any of the clarifying parts about that, like if I didn't answer your question exactly, please comment on this on Classroom and I will clarify. All right, so that brings us to the FRQs for the test on Thursday. So the first one here actually asked about D2, not D1, but D1 is going to be directly related to it. So I'm going to do D1 so I can explain it this way. So D1 is just asking you to write the electron configuration for selenium. Selenium has 34 electrons. Okay, that part I think everyone can do. And then the second part, would you expect selenium to be paramagnetic or diamagnetic? So before we talk about selenium, the question actually asks what's the difference between paramagnetic and diamagnetic. So before we get to this particular question, I would like to explain what those two terms mean a little bit more. Paramagnetic means that there are some lone electrons that are not in pairs. So for example, carbon. That's the electron configuration for carbon. And it looks like, when you're looking at this, that it actually, they are all paired. Look, there's a pair in 1s, there's a pair in 2s, and there's a pair in 2p. But you know that when you actually do out the orbitals, those two are paired, and then these are not. So these are unpaired electrons, which means it is paramagnetic. Magnesium, they are all paired. Okay, so that is diamagnetic. They are all paired. The reason I picked magnesium is because it is not a full outer shell. It's not like it's like the three is not full, okay? It's not a noble gas, but it's still diamagnetic because all of the electrons are paired, okay? But in carbon, they are not. So let's see about selenium. Now, to make this easier on yourself and to save time, I would not worry about doing all of the stuff until the very end, right? Because you know all of those are paired unless it's one of those electron configuration exceptions, which selenium is not. So let's just look at P4. So if we had 4p4, it would look like that. So are there unpaired electrons? Yes, there are. So it must be paramagnetic. And your explanation would be there are two unpaired electrons. Okay? Now you might notice they did this on purpose. They gave you one that has an even number at the end because they want to make sure you know how this works, that you put one on each orbital before you start pairing them, right? They didn't give you something that's 4p3 because that would be too easy. Obviously, you have an unpaired electron there. They're doing this on purpose. That what they're testing here is not only if you know the definitions, but also if you know this rule. All right, the next question, well, I'm going in order of the FRQ, so it's actually the last question on the document, but the next question in order is 3B1. On the basis of the Lewis structures drawn in Part A, answer the following questions about particular species indicated. Is SeCl4 polar? Explain why or why not. So the question that was posed on the document was, how do you tell if something is polar or not? Okay. So there's going to kind of be two parts to this answer. The first part is if the shape is symmetrical, then it's nonpolar, and if it's not symmetrical, then it's polar. So that will work for the basic ones, like linear. Okay, like if you had linear, for example, CO2, this is linear, it is symmetrical. It is the same on the left and the right, and the top and the bottom. Okay, that is a linear shape. Also tetrahedral, which is kind of a little bit on paper doesn't look like it is symmetrical. It is. Okay. How do we know that? They are all the angles are the same. They are all 109.5 degrees. So that brings us kind of to the second part. The second part of this is if they are the shapes that I said you don't need to worry about knowing, the more complicated shapes, take a look at the bond angles. If there are two bond angles, then it's going to be polar because that means it's not the same everywhere. If there are two, if there are all the same bond angles, or for example, like square pyramidal, they're both 90, then it's probably non-polar. So let's take a look at SECl4. SECl4, the Lewis structure, which you would have done up in A. 6 plus 7 times 4. So you would have Se in the middle, 4 Cl's. And that gives us 32. So we have 2 left over. So we have a lone pair. That gives us 5, 4, 1, which is a trigonal bipyramidal. Trigonal bipyramidal has 2 bond angles, 90 and 120. So no, I'm not going to draw out the shape, but you just know it's not symmetrical because there's 2 different bond angles there. Okay, so that means it's going to be polar. The reason why something is polar is because all of the dipoles do not cancel out. Okay, actually, I'm looking at the answer key right now, and it gave us exactly the same explanation that I've been giving the whole time. It says SECl4 is polar. The unshared pair, meaning this extra right here, makes it trigonal bipyramidal, which means it's not symmetrical and it's polar. So you can just say it is not symmetrical because those bond angles are not the same. Okay? Now, one caveat here. Please also use your common sense for the more basic shapes. Meaning, sometimes the chart is not going to say that there are 2 different bond angles, even though you know, based on your common sense, there is. For example, bent. We don't talk about this angle right here. So you'll see on the chart, it just says it's 120 degrees. Use your common sense for the basic shapes, okay? For the more complicated ones, it does spell it out for you, but here it just says 120 because it's just talking about this angle here. But you know that a bent shape is not symmetrical. Those 2 angles are not the same. You know that, okay? So also use your common sense. But for the more complicated ones, because you can't visualize them easily, you have to be given the angles. So that's a general overview of polarity. Next, we have the experiment question. Okay. So this question said, what? Nope, that's 6A. Sorry, I was thinking of the wrong one. Would the ratio be smaller? There'd be more actual mass of ZnCl2 compared to heating it with a stronger partner. Okay, I'm really glad that someone asked about 5C and 6A. I think these are very important questions for us to go over. So this one, 5C, is one of those error analysis questions, and we've been talking about those throughout the year, and you probably will see one on your AP test. They're very common. So the first thing you should do, first of all, don't panic. You know what to do. you are going to take a look at your data table, which is why I copied it here, and say, okay, what of these numbers is going to be affected by this error? So this error in this particular case is the student does not notice that some soot deposits on the bottom of the dish during the heating. Okay. Obviously, it's not going to be the mass of the empty container before the heating. It's not going to be the initial before the heating. Probably after the first, we don't know when in the heating that it would be affected. So it could be any of these three numbers. Those could be affected. Okay, so now go back up to the earlier parts of the question, A and B, and see which of those numbers you actually used. You used the last one. Okay, so this is the number that you used that's going to be affected. So that's the first step. Figure out what number is going to be affected. Then you take a look and see, where did you use this number? You used this number in B1 to figure out the water lost. You subtracted what you started with, and then you subtracted this number, okay? So if in B1, and then that gave you, so you had, I'm just going to say water. It's easier. Okay, so take a look. If this number was bigger, what would happen to the water? The amount of water would be too low, right? Because if this number was bigger and you didn't notice, then the amount of water would be too low. You then use that, because that's mass of water, to put moles of water, and then it says ratio of water to anhydrate. So if the water was too low and you're looking for the ratio of water to something else, what's going to happen to the ratio? It's also going to be too low. Okay, it's as easy as that. Whenever you see this type of problem, first look at your data table and see what would be affected, and then walk it through the calculations. Sometimes walking it through the calculations is more complicated than it is here. This is a pretty easy one. Sometimes you have to go through more steps, but you just walk it through the calculations until you get to what they're asking. They're asking here for the ratio, so we can stop right here. It will be smaller. Okay, and the last question I want to go over is 6A. This is also a really great question because it is a very common type of question, but I don't think whoever wrote this question on the document is going to love my answer to it, because the question on here says, how many steps are fully needed to answer the question? And there is no answer to that. You just need to make sure that you answer the question entirely. There is not going to be a set of steps that you have to have. I'm not going to say 17 or 3. I'm not going to tell you how many you have to have. You need to figure it out, and every single one of these types of questions is going to be different. However, the biggest mistake people make on this type of question is that they do not start by dissolving the sample. When it says you are given a mixture containing zinc chloride and potassium nitrate, you have to assume that that is just a mixture of the solids. Unless they say it is already in solution, you have to assume it is just the solids. The biggest mistake people will make is they will jump right to adding the AgNO3 to precipitate out the AgCl. They'll jump right to that. And then they'll talk about the separation, which I will also talk about. If you have a sample, you have to dissolve it first. And quite frankly, if you folks roll a 6 for the exam on Thursday, I'm going to know who watched this video because almost always, if people do not know to do that, they don't do it. So if you are given a sample, and like I said, this is a common type of question asking you for procedure. So on the AP test, you might be given something like this. You have to start, dissolve the mixture. And I'm going to say in excess water. I don't think they would be that picky about it, but that's what I would do. Very, 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 very important. You need to have that in there. Okay, then you can start precipitating out the Cl, and then the second part of what this question is getting at is making sure you know about filtering it out, which we did first lab this year. So it's a while ago, so I'm really glad someone asked about this so we can go over it. Then you're going to add plenty, we like the word excess in science, because you want to make sure that the AgNO3 is the excess reagent, because we want to precipitate out all of the chloride ion. And again, you don't have to have these exact words, you just have to have the basic idea. Okay, then you're going to have a solution that's going to have AgCl, which you know is insoluble, whatever. Next thing you're going to do is filter it out. Here's another important thing. Mask the filter paper, because you're going to need to subtract it at the end because your sample is going to be on the filter paper. Okay, and then I'm just going to say something like filter out the AgCl, right? You can just say, because we're just going to drip it out, like you just put it in the filter and drip it out in the funnel, however you want to say that. I would definitely put something in there about like washing it with a wash bottle. To make sure you only have AgCl. Then make sure you dry it, and you can say however you want to dry it. I think when we did it at the beginning of the year, we just left it overnight to dry because we had a weekend. You can also put it in an oven to dry it, but you're going to dry. And then you're going to mass it. So that's how I would kind of do it. You can definitely do that in fewer steps. You can put it in more steps, um, however many you want. This is a very common procedure to be asked about on the AP exam, so it is kind of nice, just a basic filtration. They do like to ask about that. We will also have just some common experiments that you're expected to know, or we'll have that over April break. That will be part of your review for April break. Um, so that will be coming as well, but this is a very common one, so it's a great one to just kind of have in the back of your mind um, as a helpful one. All right, so that's all that was asked. Again, if any of these questions didn't actually, I read them incorrectly or anything like that, just comment on the document and I can clarify for you.